Right. So, students, uh, let's start with first lecture in sequence and series. Now, what is a sequence? So, it's set of numbers, maybe 2, 4, 5, 7, 9, 10. See, students, these numbers, the successive numbers, may have a particular formula, particular pattern, which is recurring or may not. That is a sequence, just collection of numbers. If it is collection of finite numbers, we call it finite sequence. If it is collection of so many numbers, so it may be infinite sequence. All right. So now comes uh, what is the difference between sequence and series. Now, let's say we have some numbers, let's say the same set of these numbers. It's a finite sequence. So now, in case we add plus sign in between all the numbers, it becomes a series. That's all. Simple difference between a sequence and series. Now, one more interesting thing, we're not able to really find any pattern. As a result of that, we can determine the next number, but there might be some complex pattern which we are not able to see in a sequence, right? Then comes, what is the difference between a sequence and arithmetic progression? Now, you see, there can be a sequence like maybe 1, 1, and then you add two terms, 1, 1, this is 2, then you add these two terms, 3, you add these two terms, becomes 5. Now, this is a particular type of sequence which we'll be discussing later on. But then there's no particular pattern which can define the successive numbers, all the successive numbers. But then if we talk about 1, maybe 3, 5, 7, 9, 11, now we can see each successive term comes as a result of adding 2 in the last term. Each successive term comes as a result of adding some constant number in the last term. Now, every successive term in the sequence can be defined by this pattern, that there is some first term, and the first term, we are adding something in the first term, we get second term. We add something in the second term, we get 5. We get 2 in 5, we get 7. We add 2 in 7, we get 6. This, a particular pattern is defined. A particular constant is defined, is known as, or the sequence is known as arithmetic progression, or simply arithmetic sequence also. Now guys, when you talk about arithmetic progression, it is defined as a sequence, let's say A1, A2, A3 till AN. Now it's finite. If it is still extending till infinity, it is infinite sequence. It's known as arithmetic sequence or arithmetic progression. In case every term an plus 1 is equal to an plus a constant term d, which I have just explained here. N belongs to set of natural numbers. Now guys, here a1 is known as first term, And this d, which has been added to every term to get the next term, is known as common difference, denoted by d. So let's see some arithmetic progressions, maybe 5, 10, 15 till infinity. Here my first term is a1. Most of the time it is represented as simply a also. This is my second term, a2, my third term, a3, and my common difference d. Take any term, not the first term obviously, because there is no term which should be subtracted from this, which is back of this. Let's say we take 15, just subtract the last term, 10. So this is 5. And the same common difference is here also. So this is the arithmetic progression. It's arithmetic progression AP. Now guys, before going in details with AP, we're going to discuss one particular case of sequence which is known as Fibonacci sequence by a mathematician, Fibonacci sequence. What's this Fibonacci sequence? Students, here every term an is defined as last term. What is the previous term before an? An minus 1. And what is previous term before an minus 1 would be an minus 2. It's like you have 0. Before 0 you get minus 1. Before minus you get minus 2. So you could say this is an plus 0 or simply an. So every term in a Fibonacci sequence is defined as sum of last two terms. But then here some condition is to be written. What's that condition? N should be greater than 2. Why? Let's understand. Let's talk about a Fibonacci sequence. Let's say 1, 1. Now to get third term, you add these two, you get 2. You get fourth term, you add these two, you get 3, then 5, then 8. Right? It could be unending Fibonacci sequence or simply finite Fibonacci sequence if it has some defined terms. So let's say in this case every term is sum of last two terms. But can you put this definition about particularly second term or first term? No, we cannot. If you want to find out second term, as per the definition of Fibonacci sequence, you have to add last two terms, but we only have one term before this, that is a1. We don't have the previous term of an, so that's why n cannot be 2. Similarly, obviously n cannot be 1 also. N cannot be equal to 1 also. Why? Because to find 1, we need previous two terms. We don't have. So we can find previous two terms, all the previous, we can find any term in Fibonacci sequence, but starting from third term. And first term, students, in Fibonacci sequence is always equal to second term, this particular sequence. So can we name some more sequence like that? Maybe 2, a1, first term is 2, and second term will also be same. A is equal to a2, or simply say a1 is equal to a2 is same thing. The third term would be, now the formula is, you want to find any term, its previous term of n, an minus 1 plus a n minus 2. Condition, n should be greater than 2. So you can find all the terms, but the minimum, the least term you can find by this formula is third term. You cannot find second and first term by this formula. So first and second term are same. So the third term would be, that 4, then 6, 6 plus 4, 10, and so on. This is Fibonacci. This is the what we say, the example of a Fibonacci sequence. Let's do a small sum. Use 14 sum in your first exercise. The Fibonacci sequence is defined by 1 is equal to A1 is equal to A2. Right? Now it's given an is equal to an minus 1 plus an minus 2. Obviously, this is a standard value for nth term. What is n? N is nth term, second term, third term, 10th term, 15th term. And always write n is greater than 2, always. Right? So he says find a value for a n plus 1 divided by a n for n is equal to 1 and 2. So how do we do that, students? So how do we do that? Is this, see this. Now we want to find out, first you should find out all the terms of this few terms at least. This is n is 2, so we want to find third term also. So like first term is 1, second term is also 1, third term will be 2. So what will be a n plus 1 divided by a n for n is equal to 1? So this is equal to, when n is equal to 1, this term becomes a2 divided by n is 1, a1. So a2 by a1. This is 1. 1 by 1 is 1. And a n plus 1 divided by a n for n is equal to 2 becomes a3 by a2. a3 by a2 is 2 by 1, that is equal to 1. Now somebody can go further also. What is a n plus 1 divided by a n for n is equal to 3. So I must find the fourth term also. So it will be 3. So a n plus 1 by a n would be a, for n is equal to 3, it will be a4 by a3. So that is equal to 3 by 2. So that's all with Fibonacci sequence. You can find some more sums and do some brainstorming with that. All right, students. Finished with this? I've also explained you. Let's say you have a sequence 2, 3, let's say 4, 5, 9, 11. Hope you remember. In a sequence, common difference need not exist. It may exist, may not exist. If you convert the sequence into this form, 2 plus 3 plus 4 plus 5 plus 9 plus 11, it becomes a series. A main difference between a sequence and a series. Now students, having done this, in exercise 9.1 of your 11th is pretty easy. You can always do that. And now let's jump to arithmetic progression. In arithmetic progression, the definition already we have done. Nth term means first term, second term, third term, so on, is represented as a subscript n. Well, this is equal to Ishma. What is the formula for an?
A plus n minus 1 into d.
A plus n minus 1 into d. That's beautiful. So a can be written as a1 is basically your first term. N can be anything. You want to find out 17th terms. N will be 17. This will become a17. And d is your common difference. You know that. Fine. AP. There could be ascending AP. There could be descending AP also, depending upon if d is positive or whether the d is negative. You see that if d is negative, your values for successive terms will fall down. It's like when d is negative. Let's say d is minus 2. So the first term is, let's say, 10. So next term will be d is minus 2. Yes. What will be the next term? 8. And then 6, and then so on. If d is positive, first term is 10. Next term would be 12, 14, and so on. All right, that's great. So this is the first formula to find nth term in a arithmetic progression. The second formula is to find sum of n terms. Sum of n terms. Why? So sum of n terms is, let's say, Sn represented by S is sum n subscript sum of n terms is equal to the two formulas n by 2 into 2a plus n minus 1 into d. You have learned them pretty well in your 10th standard. Is equal to also n by 2. Well, this can be split as a plus n minus 1 into d is basically a plus an. And the students, there could be there could be a arithmetic progression like maybe 3, 6, 9, 12, 15, and let's say 18. So this is my 1, 2, 3, 4, 5, 6. This is my A6 and this is my A4, right? So let's say you say when n is equal to 4, what is Sn? Well, that means what is the sum of first 4 terms, right, students? When n is equal to 4, Sn or S4 means sum of 4 terms. That's equal to 12 plus 9 plus 6 plus 3, whatever it is, it comes. But then A4 is not the last term of this AP. The last term of this AP in this case is A6. So in case An is the last term, you could also write it like this, n by 2 into A plus L. Only in the case when let's say you say n is 17 and 17, there are only 17 terms in that AP. So an can be replaced by L in that case, right? So this is like, three formulas, different formulas which are used to find nth term or maybe the sum of n terms, But then this formula here also, let's say in this case also, you can take 12 as last term also. Somebody says that if you want to find sum of 4 terms, you can also use this formula also, maybe this also, and say 4 by 2 and 2a is 3, and let's say my last term is 12. All right, no problem. So it will be, like 15 by 2 into 4. So whatever it is, So this is like, you go about different formulas in arithmetic progression. Having done this, students, yes, students, there are the sums. The first sum is, in an AP, the mth term is n. Now we know that the nth term of a AP is given by, yes, Abhijit? Nth term is given by an is equal to a plus n minus 1 into d. Where d is a common difference, a is the first term, n is nth term, a is nth term, an is nth term. So it says mth term is n. So what is mth term? See, students, mth term is am. M can be any number. So it will be what? It will be again first term plus, yes, Ishma, am would be first term plus, can you say that?
m minus 1 into d.
Minus 1 into d. And he has given that this is equal to n. If I'm right. And the term is n. He has given that. This is my first equation or whatever it is. Let me just write this. And then it says nth term. So nth term is an is equal to, again, first term. Since this value of subscript is n, so I'm going to subtract 1 from this subscript only, n, and minus 1 into d is equal to m. He's given that. All right, he's given that. So now this may be 1, this may be 2 equations. So if I do equation 1 minus 2, now you might ask, why not you do so 2 minus 1? You can do that also. You can try that also, no problem. So when I subtract 2 from 1, a will cancel and I will get m minus 1 into d minus n minus 1 into d would be equal to n minus m. You know that whenever you want to subtract some equation from some equation, write down the left hand side of the equation from which you want to subtract, and then write down the left hand side of the equation which is to be subtracted. same thing is to be repeated on the right hand side. So you see that, students, if you open this, it becomes m d minus d. So this is like minus d minus n d, and it becomes plus d. Am I right? So right. So it's like minus md minus d, and then nd minus nd plus d is equal to n minus m. You see the, students, d is cancelling. So you can always take d common again here. Or maybe you can take minus d common here. If you take minus d common here, you get exactly same thing on the right hand side. You get n minus m is equal to n minus m. Now these two cancel. So you get d is equal to minus 1. All right. So a lot of questions like this, students. So d is minus 1 here. When d is minus 1, I go further. I want to find pth term. If I want to find pth term, what I need? I need first term, a, then I need p minus 1 into d. I need common difference, right? Common difference, I got it, but I don't have first term. I can find first term from anyone, maybe from this equation. So students can try the second one also. The first equation is a plus m minus 1 d is minus 1 is equal to n. So you can write a minus m plus 1 is equal to n. So a is equal to n plus m minus 1, right? From this, I can put the value for a here. So I get a pth term. Pth term. AP is equal to a is n plus m minus 1 plus p minus 1 into, what is the value for d, Ishma? Minus 1. So AP, my pth term is n plus m minus 1 minus p plus 1 is equal to n plus m minus p is my pth term. So many sums, similar sums like this to be done in the exercise. So this will really help you to do those sums in exercise 9.2. All right. And then we can shift to the second sum. The second sum, it says, is sum of n terms of AP is this. There's a concept in this, students. I want that you'll catch this. The sum of n terms of AP is this. Sum of n terms means Sn. S stands for sum. Sum of n terms is actually, we know the formula, Sn is equal to n by 2 into 2a plus n minus 1 into d. Well, very good. But then he says my Sn is np plus 1 by 2 n into n minus 1 into q. Now p and q are constants, find common difference. We want to find out d. So students, you see, let's go back to basics. What was common difference in AP? The common difference is you might take any term, not the first term. You might take third term, simply subtract second term from this. Or you just take second term and subtract first term from this. We're going to concentrate here, because if we go for finding out third term using n is equal to 3, it might take more time and more labor. So we can always find second term using this, and first term, and difference of first term, second term would give me d. Now students, you just see, let's say I'm having a AB2, 4, 6. Here, what is S2? Yes, Arjinder, what is S2 in this AP? S2 is sum of first two term, that is 6. What is S1? S1 means sum of only one term. What is that? Yeah, sum of n term is 2. This is the catch, and this is also equal to A. Always S1 is equal to A. So if I want to find first term, Rishma, I will put n is equal to
1.
1. Beautiful. I will get S1. Sum of first term, since there's only one term, so you see you can add 0 with that. No, you don't add. So it's your first term a1 or a is equal to n is 1, and is 1 becomes p, 1 minus 1 is 0, and your first term is p. Or you can simply say by sum of first term is p, sum of one term. In one term there's only one term. Now, Ishma, what will be the sum of two terms? Sum of two terms means a1 plus a2, or simply you can write a plus a2, right? A plus a2 will also do, because we have assumed always that a1 we are taking as a, no problem. So student Ishma, what will be that? What will be S2? He has given the formula for Sn. So what will be S2? In this
2p.
simply put the value for n as 2. Perfectly right. 2p plus 1 by 2 into 2 minus 1 is 1. So this is equal to, shall I say, 2p plus q? This is S2. Now, don't do the mistake of subtracting first term from sum of two terms. No, no, no. First, you need to find the second term. How? The second term A2 would be what? See, suppose you want to find out second, you want to find out the, yes, this is sum of two terms. This is sum of two terms. This means first term and second term. So how you can find the second term?
S2 minus a.
S2 minus S1. S1 is A. So that is equal to S2 is 2P plus Q. And what is your S1 or your first term? You already have is P. So your second term is P plus Q. Am I right, Ajinder? Wow. You know the second term. Now what will be common difference, Ajinder? You know the second term. You know the first term. So what is the common difference? D is A2 minus A1. What is A2? P plus Q. What is A1? P. So students, Ishma, your common difference would be?
Q.
Common difference is Q. I wanted to do one more sum. I'm going to say this sum, but the time constraint is there. Zoom is going to finish in 1 minute, but then I'm going to put you on track, and students, you can do this sum. So he says there are two arithmetic progressions. Now, two different APs means their first term are different. Let A is the first term of first AP and A dash is the first term of second AP. Similarly, let's say D is the common difference of first AP and D dash is the common difference of second AP. Now, what will you do? He says the sum of what? He says the sum of n terms of two arithmetic progressions are in a ratio. Sum of n terms. So he says that means this is basically two arithmetic progression. It could be SA. I'm sorry, not SA. This is the ratio of Sn divided by, yes, Ishma, can you say? This ratio is
Sn dash.
beautiful, 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 beautiful. No, you cannot say Sn dash because n is same. The n terms are same. So you could say Sn and you can probably put a dash on this to show this is the sum of n terms of second AP. And this means sum of n terms of first AP. I cannot put dash here. Why? Because n is same. All right. So this is equal to, it's given. This is 3n plus 8 divided by 7n plus 15. Follow, do the formula and do this sum. Thank you.